Hey there, calculators. Welcome back. If you are watching these videos in order, and hopefully you are, we left off our first video with this problem you see in front of you, letter F and problem number 3 in this additional videos packet, or additional problems packet, I should say. And we got left with a 0 over 0. We call this basically an indeterminate form. Indeterminate forms are values that happen when we substitute into a limit that we can't handle. Other indeterminate forms besides 0 over 0, sometimes you'll see infinity over infinity. Basically means whatever method we've used is no good and we should be able to do better, whether that's another algebraic method or maybe a skill that we'll learn later on in this course. But if you're okay with it, I'm going to go ahead and wipe this all and start over. We always should try substituting. And maybe you're smarter than I was in the last video, and you immediately looked at this problem and went, I think we're going to have an issue putting -1 into that denominator. And again, with rational expressions, what you always want to check is that denominator. Because if the value you're plugging in makes the denominator 0, we're almost always headed for bad news. However, we have some tools in our toolbox, and one of them is one of the greatest words in all of high school mathematics, and that is factoring. We can factor sometimes these expressions that we're dealing with. So I'm going to go ahead and rewrite this problem here, and I'm going to factor the numerator. And because I'm not plugging in a number yet, I have to continue to write that limit expression. It gets to be kind of a pain. I'm sorry, I don't have a better answer for you. But we can factor that top numerator. And again, if your factoring skills are kind of up to par, cool. If you need a little more practice, make sure you ask your teacher, whether that's me or Miss Gogerty or Miss Jarosik. But we should be able to deal with this, and if you factor it properly, and if I factor it properly, I'm thinking I get x minus 6 times x plus 1. And hey, what do you know? I have a matching factor in my numerator and my denominator. So we can, just like we would normally with a rational expression, we can do the same thing here with the limit expression and treat this like the factors cancel each other out. So we have, we could write this is equal to the limit as x approaches -1 of just x minus 6. And now that that denominator that was giving us trouble is gone, we can just simply plug in that value and say, okay, well, this is equal then to -1 minus 6. Don't be that kid who says that's 5. No, that is -7. And there we are, all set, ready to go. Awesome. All right, just like we did in the last video, we're going to try a couple more. Sometimes we'll use this same factoring method. I just think if you're dealing with a rational expression, you should always look to factor first. Always, after always looking to substitute. But let's take a peek. We have a couple more down here. Let's look at letter G. Just like in the last video, go ahead and pause now. Seriously, do it. Pause it. And see if you can try letter G on your own. I will wait. Cool. Welcome back. All right. So we are going to look at this. I am going to go, oh, yay, I'll plug in my -1. But as soon as I see this denominator, we're a little upset about that. But because I'm dealing with a rational expression with a polynomial or in the numerator and another binomial in the denominator, I'm hoping I can factor, and I'm actually hoping more specifically that x plus 1 is one of those factors in the numerator. But let's try this out. So I'm going to say this is equal to the limit as x approaches -1 of some combination of 2x and x. And I think if I do this right, if I do -3 and +1, yeah, I believe that does give us exactly what we want. And again, just like we did in the problem up above, we kind of cancel out these factors And again, because we haven't plugged in the -1 yet, we still need to be perfect with our notation and writing the limit expression every time. And now we can just plug in this -1 like we would do in, heck, back to middle school. And we can say, all right, 2 times -1 is -2 minus 3 is -5. And if skipping that step of plugging in that -1 is a little much for you, you could always, of course, go back and show the steps of plugging in the -1. But the people who are grading the AP test are perfectly happy with this kind of work shown here. The thing they will care the most about, or at least as much about, is continuing to write this limit expression until you plug in that value. All right. One more here with letter H, if you're okay with it. Go ahead, pause the video and try out letter H. We have a factor here that might provide some issue for you, but I hope it doesn't. So go ahead, pause the video, take a peek at letter H, and we'll meet back in a few minutes. Okay, welcome back. What we are looking at here, and again, if I go to plug in this 2 into this denominator, I am yet again left as a very, very sad person. So we need to figure out how to factor, hopefully, this. And then there are some problems where we can't factor, and we'll talk about those in a minute. How would you factor this? Maybe you had a really awesome Algebra 2 teacher who told you to notice this is not necessarily a difference of squares. This here we have a difference of cubes. And if you don't know how to factor a difference of cubes, at this point in the class, there is nothing wrong with Googling that. It is a pattern worth knowing. It doesn't come up all the time, but it does come up every once in a while. So we are going to say this is the limit of x as x approaches 2 of some factor and another factor all over x minus 2. Now, seriously, I wasn't joking about the Googling thing. Go ahead and Google. And we do that by just typing in how to factor a difference of cubes. And apologies if you remember how to do this. That's good. I just wanted to show you that this is something we can do here. So we can zoom in, purple math, always a classic. A difference of cubes is, it's saying a cubed minus b cubed. That's going to give us a minus b times a squared plus ab plus b squared. So sweet. We are going to go ahead and use that. So that means our a here is x, and our b value is actually 2. So we know that one of the factors, thank goodness, up here is x minus 2. And then they said the remaining factor would be a squared plus a times b plus b squared. So, well, that is x squared plus 2x plus 4. And again, now we're back. We have factors that cancel. That troublesome denominator is now gone. So we can say this whole expression is equal to the limit as x approaches 2 of this trinomial right here. And when I plug in 2, I end up getting 4 plus 4 plus 4. That's kind of cool. This whole limit expression is equal to 12. Well done, everybody. There are plenty of times where we will substitute in that limit value, and we will get an indeterminate form, 0 over 0, infinity over infinity, and we won't be able to factor. There are some problems like that. Let's see if we can find any here. You know what? I had originally planned for letter K, but I think we are better off trying out letter I right here. So what we're dealing with here is a problem where I don't know about you, but I don't know how to factor that top piece. We have two radical expressions, the square root of 2 plus x and the square root of 2. Gross, and obviously we would try to substitute first, but again, you're going to get very quick at identifying that that number and that denominator do not play nicely with one another. This method is a little less intuitive, and I want to kind of show you what to do here. We use a word, and again, maybe you've seen this and remember this from Algebra 2 and Pre-Calc. It's a word that helps us rationalize this expression. You might have rationalized a denominator in geometry when you were doing some trig. We're going to rationalize this by multiplying the top, or the numerator, and the denominator by some expression, and we can do this because that expression, because it's the same in the numerator and the denominator, is going to be equivalent to 1. So we can multiply by 1 anytime we want. And watch what I'm doing here. I'm going to take this 2 plus x plus the square root of 2. 2 plus x plus the square root of 2. And what happens, in bonus points, if you remember that this is called the conjugate, that conjugate is going to basically force a difference of squares in the numerator. And so that basically means we're going to get the first term squared minus the second term squared. But because they both have radicals, we're actually going to end up with this. Check this out. Limit as x approaches 0. This term squared is just the radicand, or the inside piece. 2 plus x minus this piece squared, which again, square root of 2 squared is just 2 all over x times this whole gross piece here. And now you may be saying to yourself, the x is still in the denominator, so this limit can't be substituted. And you're right, except look what happens up here. Watch what happens. What is 2 plus x minus 2? Well, that is just x over x times this conjugate piece that we sort of created. And sure enough, watch what happens. The x's go away. Don't be like my former students in Algebra 1 and say we're left with 0 in the numerator. We are, in fact, left with 1. So boom, boom. Forgive the sound effects. And now, because the x factor is removed from the denominator, we can plug this 0 in everywhere we see it, which is just right there. And believe it or not, this whole limit expression just turns itself into 2 square root of 2. 1 over it, I should say. Awesome. There are a lot of other problems on this page, and even continuing down into the next page, which we'll talk about in the next video. Don't get too scared with things like a delta x. It's just a different variable. And maybe your teacher, whether that's me again or Miss Gogerty or Miss Jarosik, will talk about that with you in class if you ask really nicely. All right, everybody, have a good night. I'll talk to you soon. Bye.